For the Arctic Outlook competition, the objective was to make the structure as thin as possible so that it becomes almost invisible in the context of the natural environment of the crater. Well, there's nothing thinner than cables in tension. One of the first principles of structural engineering is that you cannot push on a rope. It is a very simple way of saying that ropes and cables do not offer any compressive strength. They only provide tensile strength. So for Phoenix, we had to design the structure in a way that all of its cables were always in tension, regardless of what part of the structure they were supporting. Of course, it is not sufficient to just put the cables in tension. They have to be at proper angles as well, so that they create a resultant force that matches the load that you're trying to resist and works against it. That is why in Phoenix we have the two masts in the middle of the structure. They ensure that the cables on either side do not run parallel to the central beam. That way, the components of their tensile force and the moment that they create work effectively against the load and moment caused by gravity. Without the masts, the cables would run parallel to the central beam, and their forces would be in the wrong direction, not to mention that they wouldn't even be remotely sufficient in magnitude. We also made sure that in plan, the cables radiate outward through the masts and beyond. That way, there would be resisting forces for the lateral loads, such as wind load. To really achieve the objective of making the structure as thin as possible, we also used cables for the handrails, and they are tensioned by the same anchors that the main cables connect to. The result of all of this is that it feels like the structure is floating in the air. So it is not just shaped like a phoenix, it is in a sense flying as well.